Hi, this is Mr. Rutherford. Water. A bottle is filled with water. The water is allowed to drain from a hole made near the bottom of the bottle. The table shows the level of the water Y, measured in centimeters, from the bottom of the bottle after X seconds. Find and graph a linear regression equation and a quadratic regression equation. Determine which equation is a better fit for the data. So notice our table, we have time in the top row, and we have from 0 seconds up to 220 seconds. And then in the bottom row, we have the water level in centimeters from 42.6 centimeters down to 30.1 centimeters. So we're going to enter this data into a list on our calculator. So here we'll hit the Stat button, and then we'll hit Enter for the edit. And for the L1, I'm going to enter all the times in seconds. So we have 0 seconds, and after each one, I'm going to hit Enter. So then we have 20, then 40, then 60, then 80, followed by 100, then 120. Next is 140, then 160, then 180, then 200, and finally 220. So now we need to fill in the L2, which is going to be the water levels in centimeters. So we have first 42.6, then we have 40.7, followed by 38.9. Next is 37.2, followed by 35.8, then 34.3. Next we have 33.3, then 32.3, followed by 31.5, next is 30.8, next is 30.4, and finally we have 30.1 centimeters of water. So now we have all of our data entered into the two lists. Now what we need to do is go ahead and graph this. So what we need to do is we're going to go to the Stat plot, which is second, and then the Y equals button. And we need to make sure that the plot 1 is on. It is. Let's make sure that it is all set for a scatter plot, and it is here. So we would want to, if it is off, select the on, and then come over here to the type and select here, we would have the scatter plot. So because this is all set, now what we can do is go to the Zoom button, and then we'll come down to the Zoom Stat and hit Enter, and this goes ahead and fits the window of our graph to fit all of the data points that we've entered into the two lists. So here we have all of our numbers that we entered, and notice that as we increase the number of seconds, the amount of water decreases, which is what happens in the table. So next we need to go ahead and find and graph a linear regression equation. So to do that, what we'll do is we'll go ahead and hit the Stat button, and we'll go to Calculate. We'll come down here to number 4, which notice is linear regression, and hit Enter. Enter again. And what this gives us is the A and the B, And so we'll need to go ahead and write this down. So we have y equals negative 0.057, we'll round that, x plus 41.11. So we'll come up here to the y equals, and we'll enter this in. So y equals negative 0.057 x plus 41.11. And then we'll hit graph. And notice here we do have a linear regression equation graphed. Notice that the data is more of a curve as opposed to a straight line. So let's go ahead and take a look at the quadratic regression equation and see how it compares with the linear regression equation. So what we'll do here is we'll go to the y equals, we'll clear that out. I'll come to the stat button again, come over to calculate, and now we come down, and number 5 is the quadratic regression. So I'll hit enter, and then enter again, and so this gives me y equals, and we have an a, which is, notice it's 2.103, so on, and it says e to the negative 4. What this means is I need to move the decimal over 4 spots to the left. So I have 0.0002103, and we can round that. So we can take this and say that it's 0.0002 x squared, and then our b, we have negative 0.103, so I'll put minus 0.103 x, and then our c is 42.65, so I'll say plus 42.65. So that'll be our quadratic regression equation. So we come to the y equals, and we need to enter that, so I'll have 0.0002 x squared minus 0.103 x plus 42.65. And we'll hit graph. And now, in comparison with the last linear regression equation, notice that this one here fits the data. As the data curves, so does the line here that we have, the quadratic regression equation. So in this case, we're going to say that the better fit for the data is going to be the quadratic regression equation, which is here.